Hi guys, at the beginning I wanted to create a video where I show you how a circuit called H-bridge operates and how you can use it to increase the speed of your remote control car. But it came out a little too long, so I decided to split it into separate videos. So in this video I will only explain the operation of H-bridge. If you already know how it works, then you can skip to the next video where I am connecting the H-bridge to the remote control car. You can find the link into the video description. Now let's start with our video. H-bridge is commonly used among more powerful remote control cars, and if your car operates on more than 6 volts, there is a high chance that it already has this circuit. Basically, what H-bridge does, it amplifies the signal from the microcontroller. Here's a simple explanation how the circuit operates. Let's imagine that we have a circuit with 4 switches, S1, S2, S3 and S4, and 2 control signal inputs, I1 and I2, that control these switches. If on both control inputs we have 0 volts, all 4 switches are in off state and the electric motor is not turning. If we have 5 volts on input I1, switch S1 and switch S4 switches to on state, and current is flowing from 12 volts through the path indicated in red color that goes through the electric motor. Therefore, the motor is spinning. If signal on input I1 is turned back to 0 volts and signal on input I2 is turned to 5 volts, switches S1 and S4 are in off state, but switches S2 and S3 are in on state. Also, in this case, current is flowing through the electric motor, but in this case it is flowing in the opposite direction. Therefore, also the motor is turning in the opposite direction. This is the idea how H-bridge operates, but in reality it is accomplished using PNP and NPN type transistors instead of switches. If you don't know how transistor operates, you should learn that first to fully understand the operation of H-bridge, but here is the short version. There are 2 most common types of transistors called PNP and NPN type transistors. The main thing that transistors allow you to do is to control more powerful energy source with less powerful energy source. For example, if we have 9 volt voltage source, we can control it with 5 volt voltage source, as is shown in these images where I1 is the base emitter current that flows through the transistor from 5 volts and I2 is the collector emitter current flowing from 9 volts. In case if the 5 volt voltage source wouldn't be connected to the base of the transistor, the current from 9 volt voltage source wouldn't be flowing because the transistor would be in high impedance state. In our case it is useful, because microcontrollers usually operates on something around 5 volts. If we have a transistor, we can use the microcontroller to control its collector emitter current, as in the following image. When the microcontroller outputs 5 volts, the current from 9 volt voltage source is flowing through the motor, and when the microcontroller outputs 0 volts, the current from 9 volt voltage source is not flowing. Of course, H-bridge is more complicated than this circuit, but the idea is similar. Now when you know the basic idea how H-bridge operates, we can continue with real H-bridge circuit. It might be slightly difficult to understand it right away, but you can pause this video at any time to have a better look at this circuit. If you are familiar with transistor, I am sure you will be able to understand the circuit. H-bridge consists from 2 PNP type transistors, 4 NPN type transistors and 4 resistors. The 4 transistors T1, T2, T3 and T4 does the same thing that did those 4 switches from previous example. These 4 transistors are the power transistors that are controlling the current flow through the electric motor from 12 volt voltage source. The transistor T5 and T6 helps to simultaneously open 2 of 4 power transistors and the four resistors R1, R2, R3 and R4 limits the current that flows through the base of the 6 transistors. Let's go step by step through the process how this circuit works. If the voltage on input I1 and input I2 is 0 volts, all the transistors are closed and no current is flowing. If we apply 5 volts to input I1, a small current starts to flow through the emitter circuit of transistors T5 and T3. Because base emitter current is flowing through the transistor T5, also collector emitter current can flow now through this transistor from 12 volt voltage source through the base emitter junction of transistor T2. Now when base emitter current is flowing through transistor T2 and T3, the collector current can flow through them as well. This means that the current can flow now through the electric motor through pathway indicated in red, and the motor is spinning. In case if we connect 0 volts to input I1 and 5 volts to input I2, the same scenario applies, only in this case with the transistors T1 and T4. Because current can flow through the collector circuit of transistor T1 and T4, the current from the 12 volt voltage source is flowing through the electric motor, only in this case it is flowing in the opposite direction, therefore the motor is rotating in the opposite direction as well. I hope that now you have a bit better understanding of this circuit and its operation. If you want to see how to use the circuit to increase your remote control car's speed, click the video in the top left corner. But in case if you want to learn how to use an already existing H-bridge circuit that you can buy online, take a look at the video in the bottom left corner. You can also find them in the video description below. For more interesting projects, check out my channel or visit my website at shortcutelectronics.com, and don't forget to subscribe. See you soon!